Okay, so today's episode is taking a break from what we were looking at last time, which is where we had the turtle mining and we were showing no code whatsoever. If you remember, I said at the beginning of it that I would demonstrate how this menu system works. So if I just show you that again, so on the toolkit you've got the primary menu here, and then if we choose say 4, then we've got a secondary menu here. I'm just going to try and break it by typing in 4 here. I can't remember whether I fixed this or not. Oh yes, it does. Incorrect input. Yeah, that's fine. So I just want to show you how to do that. So we'll escape from there, and we'll escape from the game for a minute because of the noise it makes. So as before, I've done a piece of code that's already set up for you so that you can test it out for yourselves. Now this one is in 2 sections. The first one is menu test.lua, which I have put into paste bin, and I'll put the link in the description below. This paste bin link here is not for this particular code, but it's for the other piece of code, this one, which runs with it. So in fact I've kind of cross-referenced them there. In this code here, that's the paste bin link for this one, and vice versa. So you need to make them both together. I'll start with the smaller one, which is I've called it menu test.lua. So just create a file called menu test, and you can put this lot in. It's not too big. You don't have to worry about the comments up here, and as I say, you can download it. So I just want to show you how this one works. So as before, we've got a main function and we've got a call to the main function. So it's relatively simple. There are no other functions. Now the bit that you won't have seen before is this bit up here. It says local menu equals require menu. Now what that does is, this is very similar to Python's import. So in Python you would put something like import menu, or in C# you would put using menu. So this is very common in, helps if I separate those out. This is very common in other programming languages. So this is Python import. This would be C#. We don't obviously need those in Lua. So same principle. We're requiring a library called menu, which of course is the other codes up here, which I'll show you shortly. Now the next thing is we're going to if I just come back and reduce the size of this a little bit so that you can see what it looks like on, I'll go back to the game, right click. You've got here choose your option, and then a series of menu items, and then type a number, Q to quit. If I actually type in Q here, it goes back to that menu. So choose your option, then you've got the options that you want, and then the prompt to type a number. So we'll just escape that again to stop the rain noise from getting in the way here, and we'll bring that back. So we want to set up the prompt here, which is the equivalent of the words at the moment, say choose your option. You could of course change that to something else, but I've just set it for the time being. So that's a simple string, a simple variable. Now here we're using one of Lua's tables, where we're going to create a table of options, and you do the table by having a curly bracket to start with and a curly bracket to finish with, and inside is basically a list. So we're now using Lua's table as a simple list. So we've got a list of descriptions. Now this one I've deliberately made very long, because that will be longer than the width of the terminal, and so we want it to cut short so that it doesn't kind of overflow and mess up the menu. I've also put in I've put 10 choices in, and also this choice won't show on a turtle, and that's because we have a limited depth. Again, if I just go back to there, In fact, what we do, if I just get rid of this weather, because this is being a complete nuisance. You may not be able to hear it, but I can. It drives me nuts. Weather.clear. Right, thank goodness for that. Okay, so if we just get rid of that, so that's the title, or the sort of header of it, and then this bit at the bottom here. So if I bring that back in, and then these at the moment I've got 9 options here. There's just enough room to have 10 options. If you can imagine there was another one here, then this line type number would be one further down, and it just gives you one spare line to type your response on. I know you could put it at the end there, but I kind of prefer it underneath, and you'll see another reason for that in a second. So we've got this list of options, which of course in your menu could be something completely different. I've got another one down here which shows a different option here. We've got the prompt being which direction do you want to go, rather than choose your option. I've got which direction do you want to go, and then these options are deliberately more than we'll show, and these are just 4: north, east, south and west. So I've put this one in as a kind of a second menu, just to show how it works. So you've set these two things up, the prompt and the options, and then you're going to make a local variable called choice and set it equal to this slightly odd way, which you perhaps haven't seen before, menu.new, and then feed it the prompt and the options. This of course will now call our menu, which is this one, which is requiring our menu.lua, which is this entire file over here. So I'll come back to that in a moment, show you how that works. But basically what the whole of this file here does is to go through the menu options, make sure that it prevents the user from being stupid, it gets the right result. It'll get a simple number, and the number will either be nil, no number at all, or a number between the options that you have sent here. So if we use the line choice equals menu new here, we're going to get one or two things back. We're either going to get nil because the user pressed the cancel and didn't want to make any choice at all, in which case we just simply say you chose to cancel the menu, or we can say you chose option number, which is the number that they chose, and of course we can interpret that as using this little bit of code here, which is where we've got options, which is a table, and the table is indexed starting at 1, 2 and so on. So the number choice which was returned can be used as the index for our options, so that if we happen to choose say 2, it would be that's number 1, this is number 2, which says second choice. So this would say you chose option number 2, which is second choice. So that's how it works there. Similar on the supplementary one here, except we've changed the prompts to which direction do you want to go. The options are north, east, south and west, and then again you call menu.new and then the prompt and the options again. If they decide to cancel, you chose to stay where you are, or if they chose a number, great, we're heading in the direction that you chose. So if they chose option 2, which is east, then it would say we're heading east. I just want to show you that in reality. So if we just pause that out the way for a minute, and we'll exit from HIS by Control T to terminate, and then we're going to use menu test. Right, so here's our test menu based on the code that I was showing you back here. So our options are first choice, which has been made into a very long string, and what this does is to cut it down to first choice which has been made I. So obviously that is as far as it will go. Any longer than that will just simply be cut off. Otherwise what would happen is that would span round to the next line and mess up the entire structure. So this is to stop that from happening. The last one, this won't show on the turtle, is indeed correct. We've got 10 choices. We've got the instructions on what to do, and we're on the final line, which is line 13, which allows you to type your answer. Now, I've idiot-proofed this. First thing I'm going to do is type a number. So I'm going to type exactly what it says, and I'm going to type the number 10, except of course that's a string. So when I press enter, you'll see incorrect input, and then it flicks back again to type number, Q to quit. I'll just repeat that to show you again. So if I type any old rubbish and then press enter, it changes incorrect input, use numbers only, and 1.5 seconds later it tells you to put a number in. Okay, let's see if I can break it another way. I'll put -1 in. Oh dear, incorrect, use 1 to 10 only. Let's try 34. Incorrect, use 1 to 10 only. I know, I'll use a decimal number. That will really mess it up. So I'm going to put 2.334, and let's see what happens there. I'll tell you what happens is that it rounds it down to 2, so you will have 2, which is the second choice. Let's press enter. You have chosen option number 2, second choice. It pauses for a minute and then runs the second. That weather is playing me up again. The second menu, which asks us which direction do you want to go, and again we can see if we can mess it up. I'll put 0 in. Incorrect use, put that in. Let's put 7 in. Okay, let's put any old rubbish in. No. Oh, I'm going to quit. I've had enough of this. It will accept quit. If I press Q, you chose to stay where you are. So that shows how the program works. And again, I just escape from that to stop the noise, and we'll come back to this one here. So that's the first part of the two programs that are working together. This is the menu test one, which should be fairly straightforward. The only thing new here for you is this require. So this allows you to use an external library, even an external library that you yourself have written. So we'll come back to the other side now. Now this is a much longer menu here. So we're just going to go through now and show you how this works. Right, so the layout of this one is fairly similar to what before, except this time we do not have a main function. The reason for that is that this is a library. It's got a bunch of stuff in it that you might want to use, and also the other thing that's different is that we have at the bottom here this slightly odd statement here that says return, then it's got an open curly bracket, new equals new. Now what that does is there is a function here called new. So what it's doing is by putting it inside a curly brace here, it's going to return the table that contains this function. So we're actually returning this whole function here back to the program that called it, which in this case, if I flick it back over here, is here. So menu is the name of the file. .new is basically saying, can I please call the new function in our library, which is of course this one here. So as that's where things start, but without this down here, this won't work as a library. You have to return at least one function to it. So let's open that up and show what's in there. Now this is fairly complex, but we can go through it and see what happens. So we are now calling this new function directly from here, and we're supplying it with the prompt and the options. So the prompt is of course in let's start with this one up here. So the prompt in this case is choose your option, and the options themselves is a table of options. So just bear that in mind while we go back to this one. So we're passing the string prompt and a table of options. Now I've put this little bit of information in here so that it reminds you, if you're going to make use of this library for yourself, that on a terminal size inside a turtle, you've got the maximum size of 39 characters across by 13 lines deep. So that's the maximum menu options of 10, and option length is 34 characters only, which is where it cuts off the excessively long one, like this one here. It'll cut it off after it's reached that number of characters. And then on a computer terminal, which I've set up and will demonstrate with you shortly, you get a little bit more space there, so that you can get 16 options in there, and you can increase the length of each option if you wished, right up to 47. Hardly likely you'll need that, but it just allows you to do it. So what happens now is that the width and height, which are two local variables that we have created here, are obtained from the built-in function for the terminal, which is term.getSize. If you remember, we used term.clear, term.write, there's various other things, term.setCursorPos, which we used last time. This simply gets the size of the terminal, which will return either 39 by 13, 51 by 19. These things are just given some default values. I've got an error number, the choice is nil. Now this one, again, a little bit clever, we may not have seen it before. We've set up a local variable called num options, in other words, how many options have we supplied, and that is by using this hash symbol next to options, gives us the number. So in the case of, if we are passing it this one, there are 11 options. So if we go back to here, num options will be set to 11 for this particular first call that we were using. Now the current line is a new variable, so that this is the line that the cursor is currently on. But instead of setting it to like 1 or 2 or whatever line we're on, it's rather oddly calling it from another function here, draw menu. And the draw menu is given both string prompt, the table of options, and also the width and the height of the terminal, which we got from up here. So we're passing those 4 pieces of information to draw menu. So let's drop that one out the way, and we'll do the draw menu one. Okay, so this isn't too complicated. Those are our 4 arguments that have been passed, the prompts that we're going to show, the options, the width and height of the terminal, and again it just does the same as it did on the previous function. It works out from the width and height and the options how many options there are. So as we know, there are 11, and this is where it starts to sort out user stupidity. If you sent it up 11 options, as I did, and you know that you can't display them, it'll say if the number of options is greater than the height, -3, so the height of a turtle is 13, so height -3 would be 10. So if the number of options is greater than 10, then the number of options is equal to height -3, which is 10. So that will automatically reduce our 11 options, which we have sent through deliberately, down to 10. So that stops that from erroring there. Now clear is a very simple function which we may have used before. It's just to clear the terminal and reset the cursor. So term.clear and term set cursor pos 1 so it sets it back to the top left hand corner. So that's nice and easy. Then it says print prompt. Now the prompt, of course, would be our in this case back here, the prompt was choose your option. So that will print choose your option, and it will print it at the top of the screen because we've already set the clear, which moves the cursor position up to the top left side. So that print statement, the prompt, will appear right in the top line, tucked neatly into the top left corner. And then we're now going to build up the rest of the menu. So again, if I can just drop that down, back to game, and we'll run that again. Menu test, there we go. So we've now got the menu has built up of a number with a bracket and then a little bit of space, and then first choice which has been made and then cut off, and then the rest of our choices all nice and neatly laid out, including the fact, if you look down here at number 10, that there's actually only one space between there, so that we've got this nice neat line up here. And then we've got type number Q to quit. So let me just clear that clear that weather again. Alright, let's do that. Good. And we'll bring the code in case we need to see that again. Right, so coming back to our menu here, we want to now display each of those options in time. So the for loop that we're running here is going to run for the number of options that we've got, which we remember we set it up here and we limited it in case it was too many. So this is going to be anything between 1 and 10. Then to make sure that we're not got an option that's too long, I've produced a local string variable called trim option, and here we're using the built-in string method of Lua, which is to get a substring. So if the original string was, say, I don't know, num options, then a substring of that starting at position 1 and going to the width of the terminal -5 would chop out 34 characters, because the width of the terminal is 39. So that will cut out the first 34 characters by using this string sub here. So that the new string that we produce there, we know is going to be a maximum of 34 characters long. So that will work on all of them, even if they're not as long as 39. It'll just return however wide they are. The next thing I'm checking is we wanted to make the, if I could just go back to this again and escape from that. Now we wanted to make the 10th option here have the lineup of 10th choice to be in line with the others. So this is a very small and purely cosmetic point, but I like everything to be perfect, so this is what it does here. So I is going to start off at 1 and it'll run through gradually going 2, 3, 4, 5, 6, 7, 8, 9. If it's less than 10, in other words 1 to 9, it'll print \T is the tab character, so it will move the first actual letter that you print in by 1 tab space, which in Computercraft apparently appears to be just a single space, so no big deal. I could perhaps have just put a single space in there, but I've used the \T here. Then we're going to add on to that string the number that we're currently on. So in the first one, this will be 1, of course, so we're going to have a tab character, then 1, then the bracket, then a space, and then another tab character, and then finally the trimmed string, so that will, in our first one, we'll say option 1, this is a very long and stop at that point. So that makes our first title. Let me just go back here, look, so first choice which has been made, so that's the 1 that you see. So I can just line this up nicely, just about. No, it's not going to work. So we got the \T, which is the tab, just moves it in a tiny bit here. Then you've got join that with the double dot string concatenation to I, which of course is the number 1. Then string concatenation again to the open bracket plus a space, which is this bit up here. And then if I is less than 10, it's then going to take to add yet another tab space, and then finally finish it with the option which has been reduced in length. So this is now another tab space afterwards. However, if the I here, which is the option is greater than 10 or greater, then it'll do a slightly different print option, which is almost the same as the top one, except it doesn't add that second tab space. So that those extra couple of lines have the sole purpose of making this look neat and not have that 10th choice starting one space further across. So totally unnecessary, but it just makes a nice neat option. So we've now set up the menu by going through all the options and printing them out one by one. And then finally we want to write after neither. Now notice that we're not using print here, we're using term.write, which is basically the same, except it doesn't add the new line character. Then it says here type number, Q to quit, and enter. So that will put that final line down, type number, Q to quit, and enter. And then that function has done its job, and it will return back to the caller the number of options which we have automatically set now to a maximum of 10 plus 3, which is the total height of the console there. So if I close draw menu down, so we go back to new here. So we said up here, first of all, is to get the current line, is to draw the menu, and then with those options that we sent in, and it'll return back the current line. Now the current line was the number of options, which is a maximum of 10 plus 3. So the current line now with 10 options or 11 options cut down to 10 is 13, which we know is the bottom line. So we've drawn our menu out, and we know that we're currently on the bottom line, line 13. Now the next loop is while choice equals nil. Now that was set to nil up here, so the first time this loop runs, choice definitely is nil. It's going to set the cursor position to the left hand margin of the current line, which in our case is now 13. Error number has been set to 0, so if error number is greater than 0, it's not, then choice equals read. Now this finally is the bit you've been waiting for. This is the equivalent of Python's input, and then open brackets. Oh, that thunder and weather is going again. Right, let me just get this out the way so that I can get rid of this. That's better. So if you've used Python, you will have used the input, and each language has its own version of that. So in Computercraft this is read. In Lua generally I believe it's io.read, so very similar, but it uses this read, and that's basically the same as input. It waits for you to type stuff in and press the enter key. We're not dealing today with the second type of input, which I showed you on the last video, where you simply hit a key without pressing enter. That's a whole different ball game, and that will take up another video at a later date. So this is using the straightforward read, where you press enter and that will give you your choice. So what we're doing is we're now reusing this one, and we're now reading what has been typed in, and it says if choice is equal to Q or capital Q, so that it doesn't matter which one you press, it'll reset it back to nil, which it was, if you remember, up here, and then it'll break this while loop. So that's the way of quitting out of this while loop. You set it back to nil and break out of it. Else, if it's not nil, this could have been, if you remember, I typed in TEN. I also typed in 0 and -1. ToNumber is again a Lua function that will convert whatever you want to put into it into a number. If it cannot be converted because you've put the word 10 in here instead of a number, then the it returns nil. It doesn't error, it just simply returns nil. So toNumber works on whatever you put in here, and if it's a real number then you'll get a number out, otherwise you're going to get nil. So that means that we can go straight to checking whether we've got nil or not. So if choice equals nil, because you typed in the word TEN and toNumber couldn't convert it, so it went back to nil. So if the choice is nil, it sets this error number, which was originally up here, 0 to 1. Let's say that you did type in a number, but you typed in 100 or some number that was above or below the menu. It checks again. If the choice, let's say we typed in 0, if the choice is less than 1, which of course will be the -1 I tried it out with, and or even the 0, or the choice is greater than the number of options, which again the number of options we've set is a maximum of 10, then we've got an error number set to 2. So all we're doing is changing the value of this error number. And then, again, just to make sure it all works properly, the choice has been reset back to nil. And then that's come to the end of the while loop. So if choice is still nil because you have messed it up and hit something you shouldn't, it will then return back to here and go through the whole process again. The only exception to that is if you had typed in the Q, then it will break out of this entire loop and then it will run from here. So if the choice doesn't equal nil, then we work on it, otherwise we're going to return nil. So that's how it works out whether we have hit the quit key, because you return nil. So just coming back to this, we've chosen a number, and we've chosen let's say like we did the first time, I put the spelling for 10, TEN, in there. It can't be converted to a number, so it gets set back to nil and it goes through the while loop again, but this time the error number has been set to 1 because we errored on it and we typed in a word. So this time we set the cursor position back to line 13, 1, and then if the error number is greater than 0, which this time it is because we've set it now to either 1 or 2, we're then going to use a different function, which is to draw the error. And again, we're going to give this function all the information we need: the original prompt, the number of options, the width and the height of the console, the error number, and of course the current line that we're on. So let's drop this out of the way and we'll see what the draw error, just close that up. Alright, so this is how draw error works. So this is probably the biggest of the functions here and probably takes the most explanation. Right, so this one does exactly the same initially. We have a local string variable called error text, which we set to an empty string. We again are checking to see how many numbers of options, because what we sent to this was still the original options list, not our reduced version. So we have to work that out again so that we end up with either the real number of options, or if it's more than 10 it gets set back to 10. Now it says here, if the error number equals equals to 1, then the error text is set to incorrect input, use numbers only. So if I had typed in TEN instead of a number, the error text will now be set to incorrect input, use numbers only. If on the other hand the error I got was of error 2, where I'd used a number but it was too high or too low, then the error text will be set to this: incorrect input, use 1, 2, and then it's going to use the number of options, which in our case will be 10 only. If we were feeding it with the smaller menu, which only had the north, east, south and west, which is of course just 4 options, this would have read out incorrect input, use 1 to 4 options, but at the moment this is running and showing 1 to 10. So we've now set up our error text, and we're next going to check whether we're using the full height of the screen. So if the current line, which in our particular case was 13, equals height, which is also 13, then we know that we're at the bottom of the screen. We've used the full screen. Now the importance of that and the reason for having to separate this out is if you are on the bottom line of the screen, let's see if we can safely go back to this without it. Yes, if you're on this line here and I type in enter, it won't show now because I've obviously fixed it, but if I hit the enter key, it will actually scroll all of that writing up by one line. You may possibly just see it as soon as I hit enter. Let's try it. No, it's corrected it so fast that we didn't even get to see it, so no worries. Let's go back to this. So what happens is that your whole menu looks horrible because everything is scrolled up by one space. So the easiest way to deal with that is to redraw the menu as you did before, so that you've got your full 12 lines of text or 11 lines of text, and then to set the cursor position to the current line, which in our case was 13 minus 1, so that makes it 12. The reason I haven't hard coded 13 in here is that because this is designed to work on both a computer terminal and a turtle terminal, and they have different heights. So by just using current line, which because we're on a turtle is 13 minus 1, this will set line 12, and this one will clear that line only. So the rest of the screen is untouched, but it will just clear line 12, in other words 13 minus 1. And then it's going to write on that newly cleared line the error text, which is either going to be incorrect input use numbers only or incorrect input use 1, 2, whatever only. So that will write that there. Then it will pause for 1.5 seconds to allow the user to see what's going on. It'll then clear that line again. This time it has to set the cursor position back to the beginning because the original line, when it finished writing it here at write error text, would have dumped it somewhere along the edge of the terminal. So set it back to the left-hand position of that line, and then write in type number, Q to quit, and enter, which of course is the exact same line that we have temporarily borrowed and written the error message on. And then again we set the cursor position back to 1, and this time back to the current line, which is 13, rather than current line minus 1, which is 12. So that's how if we're using the full screen, these lines will borrow a line temporarily to type in the text that says incorrect, use this, and then a couple of seconds later switch it back. You can, if you wish, alter this sleep if you wanted a bit longer for people to see what's in there. I reckoned 1.5 seconds was okay, but you're in control. You change it to suit what you like. So that was if the current line was at the full height. Now if it wasn't, such as when we were doing our second menu option, which was just to say which direction do you want to go, and you had north, east, south and west, then this is the bit that's going to run because it's less than the height. So we're now going to again clear the line that we're currently on, and then write in the error text as before, pause for the 1.5 seconds, clear the linelet again, and then reset the cursor position back. So a little bit simpler this time. So that will draw the error, and then once it's finished drawing the error, it'll set everything back to how it was for you to carry on. So if we come back to our draw menu text, right, so sorry, we're on the wrong one there, it was on the new text, there we go. So so if the error number was greater than 0, we would draw the error text on the screen and then give the user a chance to yet again type in their response. The system will read it and go through the whole process again. If they chose Q, okay, we'll quit. if they chose a number and it was greater than less than 0, the whole error checking process there will go through. So let's assume that we finally typed in something sensible, that we've chosen option 3, say, which is within the limits that we've set, and it is a real number. Or even if I put 3.2, let's say I chose 3.2, then if the choice does not equal nil, which it won't be if it's a real number, if it's nil, that means we've chosen Q for quit. If it's not nil and we typed in 3.2, then what this does here is it cuts down our 3.2 divided by 1 is still 3.2. Math floor will take the floor, in other words 3. The opposite to that is math ceiling, which would have taken 4. So 3.2 would be rounded up to 4, whereas math floor rounds it down. So it doesn't matter if you're trying to be smart and type in decimals, you'll still get an integer from here. It'll clear the screen again and return your choice finally back to here. So when you call this whole function new, it will return to you either nil or a number, whole number, integer, between the 1 and the number of items that you sent in the list. So I'm just going to run that one more time again, and I'll leave you to have a play with this. You can, of course, and the whole reason I put it up like this is to use this library in your own code. Just load it into your turtle. If I just drop this out the way for a minute and drag in this, so we've got this was, I believe, an empty file. Yep. This one is the menu.lua, and this one is, just come off of that, and this one is the test one. So that menu.lua, which I will put the pastebin links for both of these in, the menu.lua is the one that you will want to use and incorporate as a library, and this one is just an example of how you can use that file in your own code. Just last thing I want to do is to show you how this operates on a computer. So if I go back to there, let's just redo this one. If I menu test again, now this one we've now got all 11 of the choices in, because this one is a bigger screen on a desktop computer, and we've also got more space along here. So the turtle finished at this I, this one goes up to a very L, and then the ong line doesn't exist, but we've still got exactly the same menu system here. Again, of course, it's exactly the same program. I can try and break it. I'll type in a 0, it says incorrect, use 1 to 11 only. 12, incorrect, use 1 to 11 only. 10, incorrect, use numbers only. Do you know, I've had enough of this, I want to quit. So I press Q, you chose to cancel the menu, and then of course the other one will pop up. Which direction do you want to go? I'm going to just answer 2. Great, we're heading east. So hope that's been of help. Next video will be to continue with the turtle mining, to show you how the toolkit does a horizontal mine, and I'll let you into a little secret. On the one that you will see running, it actually mines 18 diamonds in about an hour and a half with very little effort from the player.